Hey guys, welcome back to CodeDrill. In this video, we're going to be talking about server-side rendering with Material UI. Now, before you go ahead and watch this video, I do recommend you go back in the history and take a look at the previous video that I created, and it's titled, What is Server-Side Rendering and Why Create React App Doesn't Support It. Now, that video provides a strong theoretical base for this one, and I do strongly recommend that you go back in the history and watch that video first. Now, assuming you've done that, let's go back to my little presentation over here, and let's make sure we go through some of the notes that I have for you over here. So what is server-side rendering? What is the premise behind that? Well, the server-side rendering, or SSR, is aimed at rendering your React application on the server and then putting it up on the client. Now, you might be asking yourself, what is the point of doing that? There's quite a few reasons. Now, we go into those reasons in more detail in the video that I just mentioned, but to sum it up, basically, with server-side rendering, we get a faster first meaningful paint, and the whole idea behind it is that the initial render of the application will be much quicker as opposed to a single page application. Now, the problem with single page applications is that even though they can load fast on highly performant devices and also on high speed networks, if a user is using a slow device like a mobile phone, the load time of your application can go up significantly. And that's because the single page application doesn't have any HTML markup up front. So in order to show something meaningful to the user, the application first needs to load all of the JavaScript files, and only when the framework and your application code has been loaded, only then can the application bootstrap, and only then can the user see the UI. Now, my argument is that by moving a single page application to a server-side rendered app, we can speed up the load time of the application by up to 3 times. Now, we're going to see an actual test once we finish this tutorial, but based on the test that I've done, the load time can go from something like 10 seconds to just under 3 seconds on slow 3G networks. And the other reason is that with server-side rendered apps, we get better SEO, or search engine optimization. And once again, that has to do with the initial HTML payload, because with server-side rendered apps, we get the whole HTML payload up front. Now, the next question is how? Well, how do we actually implement server-side rendering? Well, let's first of all look at the flow of the client-side interaction in an SSR application. So the first thing, of course, is the client will send off a GET request to the server. The server will pick up that request and it's going to render the component tree. So remember, we're talking about React application here. The server is going to render the entire component tree into an HTML string. And it's going to take that string and it's going to extract any critical CSS that that application requires. And it's going to inline that CSS into the string. So it's going to send off that HTML and CSS as a response to the client. And then once the client picks up the HTML and CSS, it's going to paint the web page and it's going to continue loading JavaScript assets asynchronously. So the important point here is that the application or the web page is going to be viewable at this stage. So even though we don't have any JavaScript assets loaded yet, the application will at least be viewable. So the user will at least be able to see something meaningful on the screen. Now, once the JavaScript assets has finished loading, React will take over and it's going to hydrate the server rendered markup, and it's also going to attach event listeners to the existing markup. Now, this is an important point because React will not actually re-render the whole application. It's going to rely on the existing markup and it's going to attach any events to the already existing HTML elements. And it is at this point that the application becomes interactive. So once again, the big advantage of SSR is that the application becomes viewable much faster. Now, moving on to the build setup, let's actually talk about the tooling that we have over here. First of all, a challenge that we have to solve is that we need to be able to transpile JSX server side, and that means that we're going to have to use preset React from Babel. Now, because we are going to be using preset React, we might as well use import statements. So we might as well be using ECMAScript modules instead of CommonJS. And those are going to be transpiled down to require and exports statements. Now, for development, we could be using Babel Node, which is a package that allows you to compile your code on the fly and store it in memory or in cache. Now that of course is not compatible for production environments. For production environments, we could as well be using Babel Cli. And this one is going to allow us to pre-compile our code for execution. Now what it's going to do is it's going to read through all of your code and it's going to transpile it down to React create element calls, and it's also going to transform any import statements. Now it's going to mirror the existing file tree that you have. So essentially you're going to have a duplicate of your files that are transpiled down to understandable syntax that Node.js can actually run through. Now, because we already have Webpack set up in our front-end application, we might as well use it for the server-side part. So we might as well actually bundle any server-side code with Webpack as well. So this way we can actually reuse the existing build setup that we already have in place. Now, talking about the integration, we're going to get into that in quite a bit more detail very soon, but I have to emphasize some of the points before we move on. Now, for the integration, we're going to make sure that on the server side, we need to wrap our app component, first of all, with the JSS provider component, which comes from React JSS. And that provider needs to accept two properties. One of them is the Sheets registry, and this one is the instance of Sheets registry component. We also need to provide a class name generator, and we can create one of those using create generate class name helper function. Now, aside from that, because we're going to be using theming in our application, we also need to wrap our app component with MUI theme provider. And to that component, we need to pass another set of properties. The first one will be the theme instance, and this one is going to be create MUI theme. This one is going to create a theme object for us. And the second prop we need to pass is the Sheets manager. And now this one can be an instance of an ES6 map. For the client, it's very important that we also wrap our application or the app component with the JSS provider as well. In this case, we only need to pass a class name generator. And when we wrap our app component with MUI theme provider, of course, we also need to pass in the theme instance. And that theme also needs to have the same configuration as we have on the server. Now, if you're new to this series, make sure you go to GitHub. You can find a link to my GitHub repo under this video, but make sure you go to the repo and make sure that you clone it. So you can click on this link over here, you can copy the link, and you can just fire off a git clone command to that URL. What this is going to do is it's going to copy the repo for you. And this application is basically a single page app. What we're going to be doing with it is we're going to transform it to a server rendered app. Now, I already have this application locally, so I'm just going to switch to my terminal over here, and then I'll open it in Visual Studio Code. So what we can do is we can go to source, and then inside of source we can create a new file. Let's call it server.js. What I'll do is I'll also rename index.js to client.js, and this one would be the client-side script, or the entry point for the client-side script. Now inside of the server.js file, let's do an import of express from express. Now of course we don't have this dependency yet, so we're going to need to install it. Let me go back to my terminal. I'm going to do a yarn add of express. I'm also going to do a yarn add, a development dependency of nodemon. And this way we can just monitor the changes on the server, and we can just basically restart that server if any changes occur. We're going to go ahead and create a new instance of express. So I'm going to go ahead and call express. Then we can set up a constant for the port. Let's say by default this is going to be 3000. We can do an app listen on that port. We're going to provide a callback function, and I'll pass in a template string. So let's do the http:// localhost, and we'll put in the port. And this way we can quickly reference the URL of the server. But of course, we're also going to need to eventually import React. So let's do an import of React from React. And we're going to need to be able to somehow render the app component on the server. So if you take a look at the client, the application is just simply the app component that is wrapped around the MUI theme provider. So we need to do something very similar on the server. So let's do the following. Let's do an app use. We're going to pass in a function. Now this one is going to accept two parameters as always, as any middleware in Express does. It's going to be the request and response object. So what we're going to do in the end is we're going to go ahead and send a string to the client. So this string can basically be the HTML payload that we have inside of index.html file. So we can go ahead and copy it, and we can paste it right back in. Now inside we can get rid of no script just to simplify it. We can also provide a script tag and point it to the client side script. So this one is going to be main.js. JS like this. So then we can go ahead and set up an HTML string like I said. So let's do a render to string. We're gonna pass in the app component. But of course this render to string needs to be imported first. So let's do an import render to string. This one needs to come from React DOM/server. And now if we want to pass in the app component like this, we're gonna need to make sure that this code is transpiled to React create element calls. Because of course Node.js cannot possibly understand the syntax. And of course it can't really understand import statements unless we enable a special flag. Now of course one way to go about it would be to pull in Babel and make sure that Babel can transpile it for us. But because we already have Webpack set up for our front-end build, let's also use it for server-side rendering as well. Now if you go back to Chrome and if you look for Webpack multiple targets, you can find a page over here on the official documentation for Webpack. Webpack does actually allow you to create multiple bundles. So even though you can pass in a single object as we do right now, we're passing a single object to the Webpack configuration. This only creates one bundle for the front end. We can also make sure that we create two bundles. So we can create one bundle for the server, and this one is going to be executed by Node.js behind the scenes. It's not going to be sent off to the client. It's really just for the server. And then we can create a separate bundle for the front end. And now this one is going to be sent off to the browser. And this one is actually going to be executed in the browser by the end user. So all we need to do in the end is we need to pass in an array to module export. And then we pass in the two configuration objects to it. So let's do exactly that. So what I'm going to do over here is I'm actually going to create an array over here. We're going to have two configurations, one for the client and the other for the server. I'm also going to set up a const because we're going to have a few common configuration options for both the server and the client. The things that are going to be common will be the dev tool. We're going to use the same dev tool on the front end and on the back end. We're also going to have a module key. So this one is gonna set up Babel loader for us. And I'm also gonna put in the resolve key. Now this one is gonna create an alias for us. This one is gonna alias Material UI core to Material UI core/ES. And if you're curious about the ES postfix, you can go back and watch the previous video. In this same series, number 15 talks about bundle size optimizations, and we talk about all the different kinds of optimizations you can do, and one of them is actually the ES folder. Right, so I'm gonna delete the other configuration we had below, and then let's also destructure the contents of that common configuration. They're gonna be the same for both the client and the server. Now for the client, let's do an output key. I'm gonna pass in the path. In this case, I think it makes sense for the public assets to be inside of the public folder. So I'm going to pass in the dir name to make sure we have an absolute path. This one will be a public folder. The name of the bundle is going to be main.js, so I'm fine with that. Now for the entry, this one is going to be source client.js. We can also omit the extension. As far as the server, we're going to keep it at dist folder. The file name is also going to be main.js. But the entry has to be specified. Now in this case, it's going to be source and then server. We also need to make sure that we put in a target. In this case, the target is going to be node. Now, if you're curious about target, again, we can go back to that same page. The target actually specifies what specific target this bundle is designed for. And the two most popular targets are web and node. By default, it's set to web because really Webpack was designed for client-side bundles, not really server-side. But you could also set it to node, and this one is going to optimize the bundle for server-side rendering. And now specifically what it's going to do is it's going to make sure it uses require statements to load any chunks, and it's also not going to touch any built-in modules like file system or path. So it's really optimized for Node.js. Now back in here, the last thing we need to do is we also need to provide a list of externals. Now the thing about using Webpack with Node.js is that typically we don't want to bundle any dependencies in Node.js. So for client-side bundles, we actually bundle all of our code, including all of the dependencies inside a single bundle. That's why the bundle often goes up quite a bit in size, but we have to make sure that we provide all the code for the client side because the browser is going to need to access all of that code at once. Now on the server side, this is actually not an issue because on the server side, we can just keep require statements for any dependencies. And in this fashion, if those dependencies are needed, they're going to be required using common JS syntax. So in this case, we don't actually want to bundle any code ourselves. So what we can do is we can pass in an externals key. And in fact, there's also a nice package that we can use. And this one is called Webpack Node Externals. And this one is going to allow us to not bundle the node modules dependencies for our backend bundles. So what we can do is we can grab this package name over here. I'm going to switch back to the terminal. Let's do a quick add -d of a development dependency. Now switching back to our editor, we can actually go ahead and import it. So let's do const node externals. We're going to pull them using a require statement from Webpack node externals. All we have to do is we need to pass in an array, and then we can pass in a node externals. We can just call it as a function. And now once we're done with the Webpack configuration, we can also go back to Babel or C, and we can also add in another target. In this case, we're going to target node, and we can set the target to 10. Now this is really going to depend on your version of Node. So if you're planning on hosting this application using Node 10, you can go ahead and set the target to 10. If you want to be hosting it on Node 8, make sure to put in the 8 target. The reason for doing it is because some of the syntax that we are using with ES6 Plus features, that syntax will not be transpiled depending on the version of Node. So if you're using an older version of Node, let's say Node 6, some features like async await, well, those have to be transpiled down for Node.js as well. But if you're using a more recent version of Node, like 8 or 10, those features are already available. So if you just set the target properly, you won't be transpiling those features. And that way the size of the bundle will be kept low, and also your code will run natively. Right, so once we're done with that, let's go back to server.js. Once again, we're going to be serving a client-side script from main.js. But right now, this main.js file is going to point to the public folder. So we're going to have to make sure that we set up a static directory for any of our static assets. And we could do that by using an app.use statement, and we can call an express.static, and we can pass in the name of the folder. In this case, all of the public assets will be inside of the public folder. Now, of course, our application also depends on a theme object. So if we pull in a theme, let's do an import of theme from theme. And on the same note, let's also actually import the app component itself. So we can import it from components/app. We do have the app component, but it also needs to be wrapped inside of an MUI theme provider. So let's do MUI theme provider. Let's go ahead and put the app component inside like this. And now, like I said back in the presentation, if we go back over here, apart from wrapping the app component with MUI theme provider, we also have to make sure we wrap it with JSS provider. So let's go back over here. What I'm going to do is I'm going to wrap this whole thing with JSS provider like this. Now the MUI theme provider is going to come from materialui/core/styles. We have to make sure the path is correct. And now the JSS provider we can import from React JSS like this. And now of course the JSS provider is going to expect several props. One of them is the registry, and this one refers to the sheets registry. So in this case we need to actually create it. So let's do a const of sheets registry. We're going to new up an instance of sheets registry. We also need to import it from React JSS. But this time the import is going to be a bit different. It's going to come from React JSS/lib/JSS like this. And we need to pass it as a registry prop to JSS provider. The next thing we need to pass is a class name generator, and the prop is actually called generate class name. So we can go ahead and create a constant with the same name. Let's go ahead and do that. We're going to need to call a helper function, which is create generate class name like this. This one actually comes from Material UI, so we can grab it from there along with the MUI theme provider like this. We can go ahead and also fix up the import path so it's nice and clear and readable. And then when it comes to the MUI theme provider, of course, just like before, we need to pass in the theme. Well, the theme we actually need to create. Now I've put in this import path. We don't actually have that file yet, so let's go ahead and create it. So let's do a theme.js file. Now in this file, what we can do is we can extract the theme that we have inside of client.js file, because it's going to be the same theme and it's going to be shared on the client and the server. So let's go ahead and copy it. So I'll grab that theme. I'm going to go back to theme.js and I'm going to do an export default of that theme. We're just going to need to import create MUI theme. So I'll just copy the path. Let's put it at the top. We don't need the MUI theme provider. So we're going to create the theme, and we also need to pull in the colors, of course. So cut that import statement, put it in here, instead of client.js, let's remove create MUI theme. And let's also remove theme from there. We can just do an identical import just like we have inside of server.js. I'll put it in over here. Now back in server.js, we now have the theme, but we also need to pass in a sheets manager. In this case, we can create a constant with the same name. So let's do a const sheets manager. And this one can be an instance of an ES6 map. So once our HTML markup has been generated by React DOM, we can go ahead and paste that markup inside of the string over here. So let's go and inject HTML right inside. But this HTML alone is not enough. This is really just the HTML markup that we're going to send down to the client. But we also need to go ahead and put in the CSS, the critical CSS that the application requires for the initial first meaningful paint. Now to do that, we can actually go ahead and reference the sheets registry that we have over here. So we can call the toString method and we can assign the result to these styles, or we can actually just call them CSS just for clarity. So this call is going to generate the CSS string for us. We're going to go ahead and take that string and we're going to create a style tag inside of the head section. We're going to just inject the CSS in line just like that. Now that style tag can also be removed on the client once the render has finished. So once the web page has been painted, we can actually take that style tag and we can actually just remove it from the DOM. So to do that, we're going to assign it an ID and let's set it to JSS styles like this. I'm actually going to go ahead and quickly replace any double quotes to single quotes. So once this is done, we can actually go ahead and try to build it. So back in package.json, since we're also going to be having a public folder, I'm going to add it over here so that we remove both the dist and the public folders together. We are not going to have any Webpack dev server, so we can safely remove that line. In fact, what I'm going to do is I'm going to take Webpack dev server, I'm going to copy its name. Let's go back to the terminal. I'm going to do a remove, yarn remove of that package. We can also remove another package, which is called HTML Webpack plugin. That's because we don't really have any HTML files to serve. We really just serve up the HTML string ourselves, so we can just go ahead and remove that plugin altogether. On the same note, we can go back over here and we can also remove the HTML index.html file that we had before. And now the start script, we can actually just change to node dist/main.js, and this is going to be the server generated script. So without actually going any further, let's actually go ahead and try to build it first without trying to run it. So let's do a yarn build. Let's see if this command succeeds. And it looks like it did. So if we go back over here, we're going to see a dist folder with the main.js file, which doesn't have anything. And now this file is going to contain all the code for our server-side application. But we also have a public folder now. And this public folder contains the main.js file, and this is really just the client-side bundle that's going to be served up for the browsers. And now before we start up the server, let me just fix a typo over here. I forgot to do a console log of the path, and that's the whole point of doing the callback. So let's fix that. But we're going to need to rebuild. So let's do a yarn build once again. So once that's done, let's do a yarn start. So we can go ahead and visit the URL. And this is actually going to display the application for us. But we're not really done yet. We also need to make sure that we go back and fix the client-side script as well. So let's go back over here, and inside of client.js, we already have an MUI theme provider, but we also need to wrap it with JSS provider as well. So let's make sure we do that. So I'm going to go ahead and put in the MUI theme provider instead of JSS provider. And once again, in this case, we also need to make sure that we provide a class name generator. So let's do a generate class name prop. We can create a constant with the same name. Let's do exactly that. Generate class name. We can call create generate class name function. This one comes from Material UI, so let's pull it in as well. Like this. And now the JSS provider itself, we can actually copy it from over here. We can go ahead and paste the same import path. Now the last thing we need to do is we also need to make sure that we delete the server-side rendered style tag. So to do that, we can actually put in a callback. Now this callback is actually the same for the render method as well as the hydrate method. Now in this case, we're doing server-side rendering. So actually, instead of render, we need to call hydrate. Hydrate is specifically designed for hydrating the server rendered markup. And this way the application won't be rendered again, and it's actually going to reuse the existing markup. It's going to, once again, like I said before, attach the event listeners to that markup. So we're going to need to call hydrate, but we can also pass in a callback. Now that callback is going to be executed once the application has been mounted. So once the app has been mounted, let's do a document get element by ID. We're going to find that element by ID, and the element we're looking at is that style element. So this element over here that has an ID of JSS styles, we can actually copy it, and in newer browsers we can just call remove on it. Now for older browsers you're going to need to do something like parent node dot remove, and then you need to pass that same get element by ID so you can actually extract it to a constant. But assuming that this is not going to be used for something like IE, I'm just going to do a remove call on that node. Now, speaking of the client-side bundle, we can actually go ahead and make sure that that bundle is loaded asynchronously. Now, to do that, we can just simply put in an async keyword to that script like this. So this way the application won't have to wait for that script to be loaded, and it can actually continue rendering without it. And this is exactly what we need. So let's save it. Now for development, I'm going to go back to package.json. Let's actually go ahead and create another script. We're not going to have any serve. Now on the same note, I can actually remove the serve dependency. The serve package for us was useful for a front-end application, but we can do a remove of serve. And once it's done, we can actually remove the serve script. We're just going to have a start for the final bundle once everything is bundled up. But for development, we're going to have a watch script. In this case, well, what do we want to do? Well, we want to call webpack with the watch flag. We also want to pass in the mode assigned to development. We're going to be watching it. And we're also going to spin up node mod. And node mod is going to point to dist main file. So we can actually omit the JS extension over here. And actually the last thing I'll mention is that for development, it's also very useful to be using hot module reload. Now it's a bit tedious with webpack dev middleware, and there's also another package called React hot reload. We're not really going to be going that far, but just to do it in a very simple and efficient manner, we're going to pull in another package called reload. This one is actually very, very useful. And it basically allows you to watch the dev server and reload the web page for your front end once something changed server side. So to set it up, well, first of all, we need to install it. Let's go to the terminal. Let's issue a development install command of reload. And to start using it, we can go ahead and call reload on the app instance of Express. So we actually need to pull in reload. Let's go to our server.js file. And over here, just above the app component, I'll do an import of reload from reload. What we need to do is we need to call reload on the app. So let's go ahead and do reload and pass in the app. So it's going to be called as a function. Now, two things you have to keep in mind. Reload is only going to be used for development environments. So we need to find a way to determine whether we are working in a development environment or a production environment. So we can create a constant. Let's call it dev. And conveniently for us, Webpack actually provides a process env node environment variable. And if that variable is indeed set to development, we can be sure that we are working in a development environment. So we can actually put in an if statement, put in the condition inside of it. And if it's true, if we are indeed working in a development environment, let's set up reload. Let's make sure that the front end reloads if anything on the server changes. And now the other thing you have to keep in mind is the way that we've set up our backend is that any request to the backend will be handled by this middleware over here. So anything coming into the Express server will be caught by this handler. So even the reload command itself, if we put it below the app use statement, this one is actually not going to be caught by this statement. The reload request is actually going to be handled by this handler function that we have over here. So we need to make sure that we grab that call or grab that setup code and we put it right above the app use statement. So before we catch any requests, we have to make sure we have our reload command right above it. Now the last thing we need to do is we need to set up a reload script. So this is actually fairly trivial. All we have to do is we need to provide a script with the path to reload.js file. So let's do exactly that. Inside of our HTML string, we can put in another script. And this one is going to point to reload.js. And we can also make it asynchronous as well for performance. But now this script is only going to be needed for development. So we can also put in another condition here. So because this is a template string, we can just put in another string over here. Now we can put in a condition. So let's do a ternary. If it's a dev environment, we're going to put in a script for reload. Otherwise, it's just going to be an empty string like this. And now the last thing is that I actually made a mistake with the Sheets manager. Of course, this variable called Sheets registry has to refer to Sheets registry export from JSS and not Sheets manager. That's a mistake on my part, so I apologize for that. And lastly, to avoid some of the warnings in the terminal, we can also go back over here. And to set up a proper entry for our application, we could just set it to dist main.js. This will be the compiled bundle for the server-side app. Back in the terminal, we can do a yarn watch once again. And this is going to compile all of the files for us. And this is also going to start up the server. So if we open it up, we could do a refresh. On the page, you could see that it actually loads up pretty fast. And that's because we already have all of these styles embedded into the HTML payload. And we also have the HTML payload itself. So the application is really rendered on the server, but it's booted up on the client to make it interactive. Now, if you go back over here, of course, we don't get any warnings, but we do get a weird behavior with the bottom section over here. So if you refresh the page, you could actually see a minor flickering at the bottom with the footer. Now this behavior actually has to do with one of the functions that we're using. And if we look for it, if we look for width, this function that we're using over here to compute the type of the device that we're using, it actually has a limited server-side support. Now this is actually quite easy to fix. All we have to do is we need to go back to theme.js. We can pass in another configuration over here. We can pass in a props key. And then for MUI with width component or function, we're going to pass in a configuration. Make sure to spell the key correctly with all the caps. And we can pass in the initial width. And in this case, it makes sense to set it to large. If you assume that most of the users are going to be using a laptop or a desktop device, you could also set it to something like medium, of course, or small or extra small. But I think it's a safe bet to assume that most people will be using a large device like a laptop or a desktop. So if we save it, it should hopefully recompile for us. If I do refresh, you see that we don't get the flickering anymore. But if we go to a mobile device, for example, let's do an iPhone. If I do a refresh, well, yes, you're going to see a flickering. But at the very least, it only happens on mobile devices and not desktops. Now let's try to do a build command. So stop whatever we have running right now. Let's do a yarn build. And now if we go to localhost 3000, you see that we actually have a problem over here. So even though we get all of our styles and we get our HTML markup as well, everything seems to be rendered fine on the server. It's actually rendered differently on the client because in the client we have a different set of styles. If you look at one of the style tags, you're going to see that it actually has a bit of a different syntax. So a typical class name for a production build might look something like .jss and then the integer. So this is typically the counter that has to do with the class name generator. In this case, the class names generated on the client are different from the ones generated on the server. This actually has to do with a misconfiguration in our Webpack setup. All we have to do, as it turns out, is we need to go back to our Webpack config file. And for the node externals, we're going to need to make sure that we whitelist Material UI as a dependency. So we do actually want to bundle Material UI into our server-side bundle. So in this case, we can actually pass in an array. But it can also provide a regex expression. So let's do material-ui. We're going to escape a / to core. We'll have another /. And in this case, we'll put in star dot. And this is going to match Material UI core and then everything that comes after it. So once we save this config, once we whitelist Material UI, let's go back to our terminal. Let's do a final yarn build. And then lastly, we're going to do a yarn start. Let's go to localhost 3000. And then after that, I'm doing multiple refreshes. You're not really seeing them. but behind the scenes, we're getting a full refresh. Let me do a hard refresh. And as you can see here, we get a fully functional application. Now we get production style class names. You see that all of them are converted to JSS and then the integer afterwards. We can also see that our styles now match up the markup that we get from the server. So everything seems to be working fine. We can also, of course, interact with the application, of course, once it's fully loaded. So we can go ahead and edit exercises, delete them. We can create the new ones. The application is fully functional at this point. Now, let's actually do a quick test. Now, of course, we're not really going to go hardcore into this, but let's do a simple test. I'm going to go to Network tab. I'm going to go ahead and switch to a slow 3G preset. This is going to simulate a slow connection. So imagine if a user of your application is using a mobile device on a slow network connection, we can actually simulate something like this with a server rendered app. So let me do a hard refresh and let's see what happens. As you can see, the app finishes loading in about 2.73 seconds. It still continues to load the main.js bundle because it's quite heavy. It takes up quite a bit of time to load. But you can see that on the left, we already have something meaningful to show to the user. And this is really the whole point of server-side rendering. As you can see, in just under 3 seconds, we can actually show something meaningful to the user. Now, even though the full load still takes up about 10 to 11 seconds, it only takes up 3 seconds to show something meaningful to the user. I'll do a hard refresh once again. Of course, the page is not interactable. I can click on buttons. They're not really responding to the actions until the main.js script has finished loading, until the app has been hydrated by React. But until then, at least we have something to show to the user. And now to contrast this with the old application, let me do a quick git stash of the whole thing. I'll do a yarn command to reinstall the dependencies. This is going to take up a second. Let me do a build. So at this point, we're dealing with the single page application. It's going to do its build. So let's wait for it. And once it builds up the front end bundle, I'm going to do a yarn serve. This is going to serve up the production bundle that we just created. Let me go to my network tab. And then here I switch to slow 3G preset. Now watch this. If I do a hard refresh, you see that the application is pretty much not visible. So we have to wait up to 11 seconds on a slow connection to see anything really useful on the screen. Let me do a hard refresh once again. You don't really see anything on the left side because we don't have anything to show. That's because if you inspect the web page, there is nothing really to show to the user. We just have an empty div with the ID of root, and we just have a script that we have to wait to load, and we can't really show anything or do anything with the web page until we load that script. Once again, there's nothing to show to the user with a single page application, so they really have to wait until everything is loaded for the application to boot up and show something meaningful. Now, once again, with the server rendered app, if I do a git stash apply, we can do a yarn again to reinstall the dependencies. I'm going to do a yarn build, and then I'm going to do a yarn start finally. And then back in here, we could do a refresh. So we do have to wait for the HTML file to load, and this takes up about 3 seconds, 2.71, something like that. But the main.js is going to be loaded asynchronously. Now, once we get the HTML payload, we have all of the styles, so we can pay in the HTML. And of course, we also get the HTML markup itself. So we can actually go ahead and paint the application and show actually something meaningful to the user. So they don't have to wait the whole 10 or 11 seconds for the application to load. Now, this is pretty much it for server-side rendering, but of course, there's quite a few caveats that you have to be mindful of. The integration for server-side rendering with Material UI is quite an intricate process, and in fact, you saw me make quite a few mistakes even going through this tutorial myself. So you really have to be careful about the server-side portion of your code. You have to make sure that you pass in all of the required properties to your JSS provider as well as the MUI provider. So let's actually go through all those points one by one. You have to make sure that you create a new Sheets manager for every HTTP request to your server. And this Sheets manager is really just an ES6 map that you have to new up on every single request. Now, the other thing you also have to pass for every single request is a new instance of class name generator. The class name generator, once again, comes from the create generate class name function. So don't try to do something like this. Don't try to take the constant and new it up outside of the handler, so outside the middleware. Don't do this. Make sure you don't do this, because we need to make sure to create a new map for every request. So we need to put in the const inside the handler. And the same thing goes for the class name generator. Make sure to also not put that constant outside the handler. That constant really needs to reside inside of the handler. So this way we're creating a new instance of the class name generator for every request. And we also create a new instance of the map or the sheets manager for every request. And besides that, you also need to make sure that you also use a JSS provider with a class name generator on the client side. So for your client side script, so really inside of your client.js file, make sure that you also wrap your app component not only with the MUI theme provider, but also with the JSS provider, and make sure you also pass in the generate class name property to it. And this has to be done inside of your client script. And the last thing I'll mention, this is really just from the documentation page, but you have to be mindful of it as well. You need to be using the same version of Material UI on the client and on the server. So make sure there's no discrepancy between the versions of Material UI. Make sure the bundles are created with the same version. The last thing I'll mention myself, you saw me make several mistakes. You really have to be careful with the setup. You really have to make sure you pass in all the required properties, and you have to make sure you also wrap your application component with all of the required wrapper components, and then you should be good to go. The last thing, don't forget to also pass in the styles, the critical CSS styles for your server-side render app, and then also the HTML markup. You can also make that client-side script asynchronous by passing in the async keyword. And you can also remove the server-generated styles by passing in a callback to the hydrate function. So that's about it for server-side rendering with Material UI. I'm also going to include a bunch of links inside of the description section for this video, so make sure to also check out those. So if you want to leave any feedback, just put it down below in the comment section. And I hope you enjoyed the video, so I'm going to see you in the next one. Take care.